Hi everyone, my name is Jane Thomas and I am a Senior Science Communicator at the Integration and Application Network. And today we're switching gears a little bit, moving on from conceptual diagrams to talk about data visualizations. So I'm going to be going through some theory and ideas about data visualization and then show you a bunch of examples of before and after data visualizations as well as good examples. Okay, let's get started. What is data visualization? The goal of data visualization is to communicate information clearly and efficiently via statistical graphics, plots, informational graphics, tables, and charts. Effective visualization helps to uncover trends, realize insights, explore sources, and tell stories about your data. And a good data visualization makes complex data more accessible, understandable, and usable, which should always be your goals when presenting your data. So one of the kind of pioneers of information design is a guy called Tufte. We went to a seminar of his several years ago, and so these are kind of the take-home messages of his day-long workshop. First of all, make sure you integrate words, images, and numbers into your data visualizations. Your visualizations should be content-driven, that is, the data should drive the design and the final product. The presentation of the data facilitates thinking and interpretation of the data. So the presentation or design should help in interpretation. Using small multiples helps to maximize content variation while minimizing style variation. So the only thing that changes is the content or the data, which is what you actually want your audience to focus on. And knowing your content and audience is important in terms of how simple or technical your data visualization should be. Using humor and hyperbole can be effective, but it's probably best done in small quantities in a scientific context. And Tufte also coined this term Sparklines, which he calls data words. So they're very small, word-sized graphics, like the one here showing glucose, for example, over time. And I'll talk about Sparklines a little bit later on in the talk. Another good data visualization site is Information is Beautiful. This is another one that we like. There are lots of data viz websites out there. This just happens to be one that we like a lot. And we went to a seminar by this guy as well, and these are his top 10 take-home messages. The first one is to have fun. This process is fun, finding out new insights and stories and getting the creative juices flowing in the design process. So don't forget to try and enjoy it. Influence yourself by looking at data visualizations online to get ideas and inspiration. Make sure you have a hierarchy of information, so structure the visual hierarchy of your image to guide the reader through your visualization. Visual language is important, so try to add a visual element such as an icon, glyph, or a shape wherever possible. And less is more. What can you take out to clean up the message and to get rid of all the unnecessary chart junk, as we like to call it, on your visualization. Grids are good to use a mathematical grid to harmonize your layout by aligning things. Color is important, and you can use the subject matter or your data to inspire a color palette or use some kind of appropriate colors for the content. Reskin the wheel, so don't throw out your pie line and bar charts. They're the bread and butter of scientific data presentation. Just design them better, and that's exactly what we're talking about today. Make your text work harder. Text is also a graphical element, so make sure you design it to be a graphical element of your visualization. And fonts speak. What does your chosen font say? And I'll talk about fonts in a few slides as well. So this is the kind of the Venn diagram of what makes a good visualization from the Information is Beautiful website. So the overall kind of 4 elements are the information or data, the story or concept, the goal or function of your visualization, and then the visual form or the design of the data. So when all of those intersect, you have a successful data visualization. If one of those elements is missing, it's not an informative or good data visualization. So try to think about all of those 4 elements when you're designing your visualizations. So from a technical point of view, the tools or techniques for better data visualization include color. Everything's in color these days, so make it meaningful and use it to make sure your visualization is visible and easily interpreted. You can go to websites and upload images of your graphs and figures to see how they would look when someone with color blindness sees them. So it'll show you if you need to change your colors or contrast, patterns, things like that to make it more easily interpreted. And on that note, red and green can be loaded colors, not just for people with color blindness, but also because, red can often mean bad, green can mean good. So just keep that in mind when you're using those colors. Make sure everything is big enough to actually be legible. All the elements are clear in your data visualization. Make sure the fonts are simple yet readable. That's very important. Informative labels and titles on your visualizations increase the information density of your product. And at the same time, make sure you remove all unnecessary lines, tick marks, grids, and other chart junk that just obscure the data. Be consistent with your formatting choices in terms of your color choices, your fonts that you use, the size and shape of your icons and markers. And make sure you save as an appropriate file type for your final product, whether that's a website or a presentation or a poster. And I'll talk about that in a minute too. So fonts. Make sure the fonts are easy to read. There's two basic classes of fonts. There's serif fonts and sans serif fonts. So serif fonts, the one on the left, you can see the serifs are those little strokes on the ends of the characters. And some example of serif fonts that are pretty commonly used, Times New Roman, Cambria, and Palatino. On the right, we have sans serif fonts, so they don't have those little strokes at the end of the characters. And some examples of common sans serif fonts are Arial, Calibri, and Helvetica. And generally, sans serif fonts are more readable from a distance. So things like posters and presentations generally use sans serif fonts. I like them for most applications because they kind of have a bit more white space without those little strokes. So it just makes them look a bit cleaner than serif fonts, in my opinion. Use color modes correctly, and this will depend on what your final product is in terms of whether it's a poster or a presentation or a website. RGB is red, green, and blue color model, and so it's transmitted light. So you want to use the RGB model on your figures and graphics that will end up being displayed on a screen, whether that's a presentation or a website. And you can see from the graphic on the right that in the RGB color model, adding all the colors together gives you white, and the absence of color results in black. The other color model is CMYK, which is cyan, magenta, yellow, and black. And this is for printed ink. So if you've ever changed the toner on a color copier, you'll know that there's cyan, magenta, yellow, and black toner cartridges. So, obviously this is best for printed products like posters, journal articles, newsletters. And in CMYK, when you mix all the colors together, you get black ink, and the absence of color results in white, or, it just allows the background color of the paper to show through. So again, CMYKs, save your files as CMYK if you're using them for printed products. Okay, so there's two main types of images. There's vector images and raster images. Vector images are made up of vectors. They're, lines. They can be infinitely zoomed in and magnified without losing any quality or getting pixelated because they're not actually made up of pixels. Raster images, like the one on the right, are made up of pixels. They have a finite number of pixels, so if you keep zooming in, you end up getting a pixelated image like that one on the right. So vector images are good to work in, and software such as Illustrator, which you've been using for the last few weeks of this course, is a vector software program. So the file types that support vector images are AI files, which is the Adobe Illustrator native format. And they can be CMYK or RGB. Again, that will depend on your final product, which color mode you use. Vector EPS is a more generic file type that can be used with any vector software. And again, that can be CMYK or RGB. SVG files, that stands for Scalable Vector Graphic. They can also be CMYK or RGB, and this is actually the first open standard vector file format. And it can be used online in web browsers, which is pretty cool that we can now, zoom in on things on the web and have them maintain that crisp, high resolution quality. Raster graphics are limited by their resolution. They're made up of pixels, and you can't really add more pixels to a graphic that you have. So you want to make sure you save it at a sufficient resolution for your final product. File types, common file types, TIFFs, JPEGs, GIFs, and PNGs. So TIFFs and JPEGs can be CMYK or RGB. TIFFs are generally a large file size, JPEGs are smaller. And you can see the graphic down the bottom on the left is just an example of what a JPEG or TIFF file would look like. It ends up with this white box around it, which you might not notice if you're working on a graphic in Illustrator. But when you export it as a JPEG or a TIFF and then put it onto, a non-white background, you'll see that white box pop up. So, that can kind of start looking ugly if you start having a lot of them on a page. GIFs and PNGs are RGB only, so they're really only useful for presentations and websites, things that are on screens, the RGB color model. They're both small file sizes, and they both support transparency. So you see the other images down at the bottom, they don't have the white box, so you can designate some of the pixels as being transparent, so you can put them on a non-white background, and the transparency is effective when you start layering things on a diagram or on a page. And the PNG 24 file type actually supports transparency gradients, so you can go from something completely transparent to completely opaque, and it'll support that file type, which is pretty cool. So what is the data visualization process? How do you come up with your final product? And this is kind of a flow chart taken from the Information is Beautiful site. So it starts off with some kind of inspiration, whether that's a data set that you have, a question or a problem, some kind of idea, and that kind of forms the seed of this process. So once you have the seed, you can identify your goal and audience and use that to come up with your concept of your data visualization, which is an idea that you can explain to someone else. So then from that, having that concept, simultaneously come up with a sketch. We like to do it with just paper and colored pencils. You could do it on the computer if you prefer. What your data visualization is actually going to look like. And then combine that with research into, data sets that can inform your visualization, whether it's your data or someone else's, how to analyze that data to best tell the story that you want. And then the sketch and the research come together for the design of your final data visualization. So I like to think about data visualization as a combination of function and form. Function being the data and form being the art or the design of your visualization. So on the function side, choose a visualization type that best conveys the characteristics of the data. So whether that's bar charts, pie charts, maps, etc. And then form is using design to apply color, size, fonts, and other elements that we have just talked about to guide the user or your audience through your data visualization. So now I'm just going to show a bunch of examples of before and after data visualizations. On the left here is just a bar chart straight out of Excel. On the right is the same figure, just applying some of our data visualization principles to make it look better, make it more easily understandable. So the default Excel layout, the colors are meaningless. It's just a default color palette from Excel. So I changed that to shades of red because the subject matter is actually a red macroalgae. So I let that inform, my data choices, my color choices, sorry. The legend on the left is pretty meaningless. It doesn't actually give you information about the different treatments. So I just added more information about what the experimental treatments were. I added the bay names along the bottom, and just instead of just generic region names to make them more meaningful, and I moved them down to the bottom so they weren't obscuring the negative numbers. And the y-axis title is more meaningful, including the units. And the overall title of the figure is now an active title. Gracilaria is nitrogen limited. So that's basically the overall take-home message of this figure. And I added in a little symbol of Gracilaria from our EN symbol libraries, just to kind of continue the color theme and add a little bit of a design element there. This is a simple line chart showing seagrass growth over the year. Again, the one on the left is just straight out of Excel. The colors don't really mean anything. The legend is separated from the graph. So I put the legend, actually, the seagrass names right next to the lines that they represent. So you can do away with the redundancy of having a legend there. Again, I added a couple of EN symbols of those different seagrasses to add a bit of a design element. The axis title and the graph title are more informative. And instead of having the actual data numbers, I just changed them to simple circle markers, because in this case, the actual numbers aren't as important as the overall pattern of showing, more growth in the summer months. So this will just depend on your message. In this case, the individual data numbers weren't as important as the overall pattern. Pie charts. This is again a default Excel pie chart on the left. It's a 3D pie chart. So first of all, pie charts should never be three-dimensional, because having that 3D perspective makes the wedges closer to the front look bigger, because there's more emphasis on them. And the whole point of a pie chart is, looking at the size of the wedges relative to each other. So 3D pie charts, definitely a no-no. So I rearranged a little bit. I used color to group together larger kind of overall land use categories: natural, terrestrial, which includes forests and grasslands, human land uses, and then water and wetlands. So this will depend on what your overall message is. If your overall message is looking at, human land uses versus others, this might be one way to show it. And then I put the individual land use categories around the pie instead of at the bottom. This is the same data, just I rearranged the order so that it goes from the largest land uses to the smallest. So this might be a more useful way to do it if your message is about which land uses make up the majority of the watershed, so you can easily see what those land uses are when you rank them from largest to smallest. And this is just a totally different way of presenting the exact same data. Again, they're ordered from largest at the top to smallest at the bottom. Taking out the color can actually make it easier to compare the size of the different bars to each other. And it's a very simple and clean design. I put the actual percentage numbers in the bars, which eliminates the need for an x-axis. And actually, when I was kind of researching for this presentation, there's a school of thought out there that pie charts should never be used, that there's always a better way to present the data. And one of the biggest arguments for that is that using different colors on a pie chart can automatically give more emphasis to certain wedges, because wedges that are lighter in color can appear bigger relative to wedges that are darker. So that's just something to keep in mind. And tables. We all use a lot of tables in our data. They're a good way to cram a lot of information into a small space. But you want to make them functional. You want to draw the attention to the parts of the table that are actually important. So on the left is a table straight out of PowerPoint. So, there's not really a lot of information there. There's numbers and titles, but it doesn't say anything about what the controls or the tests were. So it's easy to add a bit of information about what the experimental conditions were, tidy up the color of the background and the lines, the dividers. And in this case, I used an orange highlight box to actually draw the attention to the two cells that we're actually focusing on. In this case, it's the two results that are statistically significant. So again, it's highlighting, drawing the attention to the data of interest. So I mentioned Sparklines before. Edward Tufte coined that term, referring to inline charts. So Sparklines show trends over time in a very simple yet data-intense way. And they're word-sized graphics that can be used to present information. They don't have axes or coordinates, but they're kind of simple and highly condensed data graphics. They're really useful for showing things like ecosystem assessment and report card results over time. And this is an example of some of the different kinds of Sparklines that you can use for different data. And here's an example of Sparklines used. They're often used in a business contexts, like stock market prices over time. In this case, they're using a line chart to show sales over time, bar chart for profit and loss, with the blue being profit, the red being loss, and then an area chart showing shares over time. Here is another example of a good data visualization from the Information is Beautiful website. This is showing social networking sites, the gender balance on various sites, whether they're dominated by female or male membership and visitors. So it's using the little human figures to show, how much each site is dominated by men or women. Women in the middle, men on the right, and also how many more million monthly male or female visitors each of those sites gets. So that's an interesting way of showing ranking. It uses Sparklines, those little graphs, those little bars on the right. And it also incorporates the logos of the different social networking sites, which is another little design element. This is also from Information is Beautiful. This is actually an XY scatter plot of dog breeds. So on the x-axis, we have the data score that they calculated using the indicators on the bottom left. So it has a little symbol for each indicator, such as intelligence and longevity. On the y-axis, it has public popularity of each dog breed, and then each data point is actually a silhouette of that dog breed. So again, another design element that's kind of fun and adds more information to the chart. And now I'm just going to run through quickly a few examples of our data visualizations, some of the data visualizations that we've made here at Ian. This is a pie chart used in the Maryland greenhouse gas emissions reduction document. So again, this has a nice color palette. The major sectors have, we added a symbol, a white kind of silhouette symbol, to add more information density to those sectors. This is a cumulative line chart from the same document. This is greenhouse gas emissions by sector. So we don't even have a legend here. That's kind of redundant when you can just put the labels right on the graph itself. This is a figure I made showing light availability and nutrient loading and their effects on primary producers in the coastal bays. So generally, as nutrient loading increases, light availability goes down, and you can see the effects that has on the primary producers, going from no seagrass to optimal seagrass, and then again no seagrass at the extreme ends. This was a figure I made again for the coastal bays. We had this great photograph of a whelk shell, and I kind of had the inspiration to use that as the basis for a timeline showing the history of the coastal bays, of important events and milestones. So I superimposed this spiral arrow on top of that and added in important moments in the history of the coastal bays, and I think that ended up being a really effective visualization of that. This is a map of Assateague Island in 3 time periods: 1850, 1942, and 2005. And so this shows the migration of Assateague Island over that 115 years. And you can see the map on the right has all 3 of the shorelines underneath the current shoreline. So it's a nice way to visualize how far Assateague Island has moved over that century. And this is a very simple data visualization I created after Hurricane Isabel in 2003. This is the storm surge height in Cambridge. So you can see just a simple line chart, but I added a gradient of blue to make the storm surge kind of look more dramatic. You know, it's a design feature using this gradient to kind of really draw the attention to how extreme the storm surge was during Hurricane Isabel. And again, that's a very simple way to add information into your data visualization. So that's it for me. I'll see you all on Thursday. I think we want you to bring a data figure of your own to show the class on Thursday. This will be your before figure. So please don't go in and start fixing it up according to all these tools and tricks that I just told you about. Part of your homework after Thursday is going to be to use that before figure to create a fabulous after figure using our data visualization principles. And also feel free to email me. There's my email address. But otherwise, I'll look forward to seeing you on Thursday. Bye.